here from Ipyzoo. I'm really glad that you're having me here at PyCon Lithuania. There are plenty of firsts for me here, so this is the first time I'm presenting our new tool that was built for data scientists, even though I'm not a data scientist. Yeah, there'll be a lot of, some tools that I have never used before and just sort of started to learn in the last 24 hours. So there'll be plenty of opportunities to, make this go wrong. Hopefully everything's gonna be fine. Please cross your fingers for me. And yeah, so basically I'm here to tell you about what we do and to give you sort of like a deep dive to our technology, and obviously the whole reason for us to build this is to understand whether or not what we do is useful for you. So even though I'm going to do most of the talking for the next 50 minutes, I'm actually here to listen. So either at the end of the workshop, there'll be obviously some opportunities for questions, but throughout the rest of the conference and the networking party, please feel free to approach me and just tell me about what you do and how you think this thing might be useful for you. It's totally okay if it's not. So I'm not here to collect some nice compliments, more to like really understand what's going on. So where should I start? I'm not sure how many of you are familiar with this visualization. It's a famous chart classification from Andrew Bella, and basically it poses the question is like, when you know what you want to show, that's where the whole thing starts in the middle, then you can start selecting a chart for that specific reason. This is basically every other chart classification's basic logic, that you do have to know in advance what you want to show before starting to make a chart. And actually when you do it in the wrong way, or you make the wrong turn, then you have to go back to square one and think again. And this is also how we think about charts, that they are just static snapshots of data. They show us something, correlation, comparison, what else. And then when you want to get a different view of the same data set, you have to go back to coding, or just adjust some things in Excel or whatever tool you're using, and then you get a new snapshot of the same data, and it's not connected with the original one, so you have to do the connection in your brain, and this is all like super complicated, at least from where we stand, or at least from where my co-founder Andrew started his journey, who's basically a designer and a data visualization expert who is like really bad at coding and using tools with too many drop downs and radio buttons and things like that. So his approach was, why can't we just make sort of like a system that can generate all the different types of charts and work out a set of rules that enables us to do so. So he started research where he basically started identifying the different. Basically, here is just a small illustration going from top left to bottom right, how many different data series a chart can hold. So obviously a simple bar chart that's on the top left is like 2 data series, whereas in the bottom right it's like 5, 6 or something like that. And he even made his own system about it, and then his whole concept was that if we can figure out a single set of rules that can describe all different types of charts, then a lot of new opportunities arise. One key opportunity is that we can animate between these charts, since they are going to be described by the same rule set. And then comes sort of like another challenge after you've figured out the rules that describe the same charts, all the different charts, is like, how are you going to animate between these states? There are certain rules you have to keep to for the audience to make it easier for them to follow along a story and not create complete chaos. He even invested that amount of time into that, and he met with my other co-founder, Simon, and they basically built the prototype of what Ipyzoo is right now. And fast forward like a couple of years, I joined in the meantime, and we did a couple of things together to prove that this can bring some real value to the table. So we're basically like a small startup from Budapest. Then we raised some funds a year ago, and then that's when things speeded up a little. Like around 7 months ago, we released our first product, which was an open source charting library built in JavaScript. And as you can see, it can really nicely animate between different charts. And so the key like goal, that one of the goals that we had in front of us was fulfilled. It's not like the complete spectrum, because then again, let's fast forward a couple of years to the future. We would want not only JavaScript professionals, so developers or data scientists, to be able to utilize this, but also basic users. And so our vision is to create a graphical user interface for data, where you can just play around with different data sets and look at your data from different angles, never losing your train of thought, basically exploring your data set and then finding the views that you want to share, and in the meantime preparing a story, an animated data movie that you can show to your peers to share what you have found. So yeah, we are pretty crazy. I assume going up against this whole paradigm of static charts and trying to do it the other way around. When Andrew originally set out to this mission and showed his early video concepts of how this tool could be used, everybody told him this cannot be done. From that point, we've come quite far along. Whether or not we can, finish our tool, it's down to you, at least part of it. So what is animation good for? It's good for when you want to drill into details. So want to show the components of a composite chart, as in this example. Basically just filter out the things that you don't need if you want to focus on one of them, and maybe even just show the difference between the composite and the component, to have a sense of like how much the component contributes to the composite part. Or you can, when you have a stacked chart, you can zoom in on the components and see how much these components contribute to the total value. This is actually the forecast of the world's population to 2100. And as you can see, in Europe, actually the population is forecasted to decrease, even though the total number is like really increasing a lot. And just another easy example is when you add another feature, and like how much money these companies made from selling smartphones. It shows a totally different picture than just the number of phones sold. And then by zooming in on, you can show these classes of companies and how much revenue they generated. So it becomes a story, and obviously, very importantly, the audience never loses their train of thought. It's so easy to follow along such a story. It's because we use basically a different part of our brain when we want to interpret a chart and when we want to just follow moving objects. We are very well trained naturally to follow things that move around. And obviously the racing bar chart, I'm pretty sure many of you have met. There's a twist at the end of this, but I'm not going to play it to the end. You have to look for it on our site and on our public channels. I think most crucially, especially in its current state, the key benefit of using animated charts is that you don't have to always ask, like, what is it that we're exactly looking at? These are 4 views of the same data set. I'm sure most of you would be able to guess what's on them, at least on the first 3. The 4th can be a little tricky. And when I show you show these to you while they are connected using animation, it's just, everybody will understand what's going on here. It's so natural, it's so intuitive. And yeah, this is what we want to basically put to better use and have people use it in their own professional life. Just one example of the rules that I mentioned before, so that you have to keep to when you're animating. It's a really simple example of showing and hiding groups in a tree map. You can do it the right way, or you can do it the wrong way, and then everything falls apart. So what we did with our library and with the prototype that we had before, we basically built some stories for Reddit. That's how you get popular these days. I'm just going to show you a couple of these, just sort of like an illustration. So this is, for example, one about how much a cocoa bean farmer gets from a $1 chocolate bar. It's a super simple story. You could show it in, I don't know, 20 different charts. But here the animation creates tension, builds sort of like a narrative. We still have to wait until the cocoa bean farmer's share appears, so we get a sense of like how many other players get their cut, and then we have the like part to whole ratio just by the simple view. And yes, this huge ad part here is why it was thrown out even after 37,000 upvotes. Which is quite a lot. It roughly translates to around 3.7 million views. There's one, it's also super simple about the GDP, the population, and the area of continents. This is rather more complicated about the elections and how the national polling translates to a more complex thing to like, okay, we have the states, so then the candidates can win a certain number of states, but then it translates to a number of votes in each state, and then it translates to a number of electors in each state. So obviously it's a complex story, but with using animated charts the right way, you can tell it pretty like easily. And then obviously at the end, we compare the situation to the situation 4 years before. This whole thing was released 2 weeks before the elections, and the results were similar between Hillary and Trump actually. And just one last example, similar to a racing bar chart, a little different. I'm pretty sure most of you saw the miniseries of Chernobyl. They were the guys who were sent out on the roof to clean up the radioactive debris, and the red bar shows the amount of radiation they had to endure in real time, and then it puts this into some context. So yeah, this is the nice front-end part, let's say, of animated data visualization. Right now you still have to do coding to get here, but I can promise you you can actually build similar things by using ipyvizzu, and at least I hope it's easy to learn. Another example of what we built was an interactive data explorer. This shows Donald Trump's tweets. So this is the number of tweets that he sent from his account back from 2009. We were missing like half a year, but that's not very important. So this shows which platform he sent these from, like his web, his Android phone, his iPhone. This is the point in time, by the way, when he was elected president. So his Android phone was obviously taken away. And there were some other tools that he used. My favorite insight is like, this is the number of tweets he sent and how many times these tweets were shared. He obviously became much more interesting for the public when he became president, or when he became a serious candidate for becoming the president of the United States. But this is an example when the user, so it's like an interactive report. The user can walk around and check the data from different angles, split the view. Yeah, sometimes my video card glitches and then the picture goes for like 5 seconds, but no worries, it's going to come back soon. So they can walk around and look at the data from different angles. As you've seen, we've just splitted the view to see it. Yeah, let me check. Yeah, here it is. And then you can see the total number of tweets as well, or you can see when these tweets were sent on a 24-hour clock. If we stack the results together, then obviously we can see 2 very apparent peaks here. And then if we filter the data based on certain periods, like when he was still a businessman, then the peak is around the afternoon. And when he became president, the peak gets to the morning hours. And here he doesn't have those famous tweet trends during the early morning hours, whereas when he was a businessman, there are plenty of those as well. And basically, it was made with the original or like the previous version, so we had to put all the buttons that were available on the UI. but it gives you the sense of how such a tool could be used for exploration, and if you put it on an interactive dashboard, I'm pretty sure people who are not very familiar with data visualization will still be able to, you know, just dig into the data and check different views. Yeah, that's another like nice part. And just a little glimpse about our technology. So the core is written in C++. This is the results we gathered with that. We use WebAssembly to enable it on the web, and we wrote a JavaScript API around it. We gathered around 1,500 GitHub stars in 7 months and got a ton of positive feedback. And just like a month ago, maybe even 2, we released our new tool, ipyvizzu, that is like our entry to the data science realm. And yeah, it can be used for now in Jupyter and in some other platforms that I'm going to mention towards the end. But and basically, technologically, we use the same stuff as Plotly does. So when you code in Python, it gets translated to JavaScript, and there's this HTML element that appears within the notebook, and that's where the magic happens. But basically, you can use Python. I think that's the most important message here. Yeah, so let's get down to coding. How much time do I have? I still have a lot. Okay, because I basically gathered plenty of materials that I want to show you. I might get into too much detail. Feel free to like wave your hands. It's like, you know, we are more interested in less details, or ask if anything is unclear for you. So, how do you start using ipyvizzu? Easiest way is to install it using pip, and then you can also use a locally installed version. I'm sure it's not gonna be very like popular. I'm just gonna keep it that way so you can make a picture. And okay, so the basic logic of Vizzu, super important stuff. We have one method called the Animate method, and we do everything within that. You draw a chart with the Animate method, then you call the Animate method once again on the same chart, and then it's going to animate to its new state. It's easy as that. The Animate method itself has two. I'm not a developer as well, so I want to use the right vocabulary. So it has 2 parameters. One that sets how the chart looks and what are, you know, the series on the charts and so on, and then the other that's an optional part that sets the animation, how the chart should animate from one state to the other. You can set different delays and just, you know, tear it apart and make bad transitions as well, just like with the example that I showed you, or, you know, use it in many different ways. So that's like the basic logic, and this part, the chart options, it has 3 properties. It has the data. That's usually given in the first time when you call the Animate method, but you can modify the data between Animate methods as well, or at a later stage. The config that basically sets like what goes where, to which channel, what the chart title is, and things like that. And then the styling. I don't think I have to elaborate too much on that. So that's like the basic stuff. And this shouldn't look like this, but okay, it has woken up, great. So some special options that doesn't really, that is for ipyvizzu, and in the original JavaScript library don't exist, is that you can use pandas oh no, this is not that part, sorry. So yeah, you have to just import the chart part. You can set the width and the height when you're setting when you're creating the chart object. There's like, because I mean the Jupyter notebook has the cells, and then you can call the Animate method in many of these cells, and obviously on one chart, and you don't want to just, you know, have to scroll up all the time to the one chart that you animate. So basically, by default, the chart will jump right beneath the cell that was last executed, where the Animate method was last called from. There are other options there, so you can actually stick the chart to the top of the the notebook when it's needed for some reason. You just have to set the display parameter to begin or to the end. And this manual part is for some specific frameworks that are not very important at this state. And you can have more than one chart. So like more than one Vizu or ipyvizzu chart within a notebook. You just have to obviously make like name them differently, and then you can animate between them back and forth. And then there is the scroll into view parameter that you can set to true. It makes the chart scroll into the view automatically when a cell is run that basically animates that chart. When manual scrolling is detected, the automatic scrolling stops. It's just when you put together a lot of animate phases and then you want to just run the whole notebook at once, then basically the chart is going to stay at the same position and the cells are just going to go around it. And you will be able to look at the end result rather than your code at this point. And you don't have to like follow the chart downwards and try to catch it. Okay, how you can add data to Vizu? There are plenty of different ways. I guess the most popular among data scientists will be pandas. Am I right? Do you agree? Not so much. What else do you have in mind?
I'm not a data scientist.
Good. What do you do?
I'm a Python developer.
Python developer. Yeah. Okay. Yeah. So, sorry. As you can tell from this, I'm new to the whole community here, and yeah. So yeah, basically you can use JSON. You can have different formats. Like here is one where we basically even though we use pandas, we don't just import the CSV or anything like that, but we add the data manually. This is a very simple data set that we're going to use for the rest of this presentation. We have some genres like pop, rock, jazz, and metal. We have some kinds of music like hard, smooth, and experimental. So yeah, we are going to have hard jazz and experimental metal and all those other things. And then we have a made-up value like that's called popularity. So like how popular these genres are. And this is one way to add the data, but if you check the docs, there are like plenty of others. And yeah, this is how this whole data looks in a tabular format. You can specify it by series, you can specify it by records, you can specify it in this very, like, at least for me, not very user-friendly data cube way or format, and then obviously you can use JSON and pandas. And once you added the data, that's when the magic starts. So yeah, this is the same stuff. Okay, so actually this should look different, I guess. I'm not happy with what I'm seeing here, that's why I have stopped. It should. Okay, maybe that's the issue. So this one also should look like this. This is a typical Jupyter notebook. I mean, I know it looks very, very differently because this is the part that I hacked together. So in order to be able to see the code and the end result right next to each other. Fine, it looks nice now. So I'm just going to run this cell and explain what we see here. The error messages disappear after the first run. Okay, so obviously the ipyvizzu was installed, and then we import these elements. There's one more, the style that we're not using here. We set the chart's width and height. We add the data from a JSON file. It contains the same data that we've just seen, and then we initialize the library with this simple command. And then we start adding data series to the axis, so to the y and the x-axis. It's easy as that. So we set the y-axis to have the popularity, so the numeric value, and then we set the x-axis to have the categorical value. And as an end result, we get a simple bar chart. If we, in the next phase or in the next time we call the animate method, put everything on the y-axis and empty the x-axis, then we are going to just end up with one column. So because there's nothing on the x-axis that would split the values apart. The elements here are actually split by the genres, but you can't see them because it wouldn't look really nice if we have one stacked bar chart all of the same color. A couple of things I think I have to mention here, that we know there are some challenges that come from using a generic chart creator. It's not very common. Usually all the different plotting engines that you use follow Abela's logic, that you first decide what type of chart you're building, and then it has certain parameters. So a scatter plot has x and y, and then it has color maybe, but you know that the geometric elements will be circles, and you have expectations in how it will look. For now, our thing is a little different, but we're working on making it more user-friendly by enabling such presets that will you will use similarly. So if you then remove the numeric value from the y-axis and put it to the x-axis, then we get to a bar chart. So it's as easy as that. I'm just calling the animate method again and again, and then Ipyzoo will just do the rest for you. This is obviously a very simple chart, and there are two functions that I wanted to show here. First one is to add a title, which is basically just within the config part you add title and the text you want to add there, and then there's a tooltip feature, and so from this point, when the user moves their mouse over the chart, you will see what kind of data is being shown there. It's as easy as that. So what can you do to change the shape of the markers? So first, let's get back to this column chart. It's a better first start. We use sometimes the set or the attach detach parameter. The set it just clears that axis and then adds those series over there. The attach detach is basically it depends on what was there in the previous phase. So it adds or removes a data series from that axis. Okay. It's like changing the geometry to area is as easy as that, and as you can see, it's going to be animating from a rectangular shape to the area, or change it to a line chart, or to I don't know. This is a very early version of a lollipop maybe, but at least the elements are circular. Or you can change it back to rectangle, and the reason why we were seeing rectangular elements is that that's the default value. That's about it. So we have some channels. They actually work very similarly to axis. You can put data series on them, categorical and continuous as well. There are 4 of these. We have label, that's going to decide what kind of labels appear on the markers, on the elements of the chart. We have color, that will obviously determine the color of the elements. We have lightness, that's like a little bit competing with the color part, but it shows the lightness, so like how dark or light one marker is. And then finally, we have size. Yeah, that's very important. Like when with the circular markers, it's going to make a lot of sense. So I just added the label on the popularity on the label channel, as you can see here, and so the labels appeared right on top of the bars. And we are trying to make this as user-friendly as possible. So when this is a simple column chart, the labels appear on top. You can actually tweak this in the style settings, but that's where they belong. We have a lot of sort of data visualization rules that we embedded here, not only to the animations. There's a question there.
Yeah, like while you're introducing these features, could you also add some ideas of when to use what?
When to use what?
Yeah.
Yes, I will have some practical examples towards the end. Obviously, maybe is it too deep? So I can give you more examples if you want. Let me get through the basic logic part. I show you some examples. I mean, obviously, when you decide to sit down and make your own data stories and animated charts with Ipyzoo, you will have to get this deep anyway. So that was the label channel. Then we have the lightness channel. This is going to obviously determine the lightness of the markers, and also the legend appeared. We can use the same stuff with the color channel, but obviously it makes a lot of sense to remove the stuff from the lightness channel, because then it's going to get too funky. It's the same thing, so the categories are there, and then we're just going to put something on the size channel, and then switch the geometry to circle in the same time, just like in the previous chapter, which will result in a more like a better looking lollipop chart than in the previous example. We have plenty of different options to group and stack data. I have to, I'm not sure it's going to work this way. First I give you a wrong example, because there's a certain logic you have to follow here, but I'm not going to. So this is a bad example when it fades, and when we go back to the original state, then I show you the way it should be done. So first you have to put these new categories on the y-axis, and then you have to put it to the x-axis. This is once more like we are in early phases. You still have to be careful when doing such things, and this is all going to be gone in a couple of ways. So and then obviously grouping is just again the same thing. I'm just putting data series from one axis to the other, and Ipyzoo does the rest. You can change the orientation of the chart very easily, which means that from a column chart you can make a nice bar chart. I'm going to give you a specific example, and I think this might be useful. So like for example, you have let's say you have yearly data, or data separated by regions, for example, sales data, whatever, of certain products, and then you just add it together and obviously in a second step you should actually remove. I'm doing it differently. Sorry, you can split the view just like with the Trump example. Then you can put it together back again. These are all as you can see, the code is really simple. But most importantly, you can aggregate this, so you can show the aggregated value over regions or over different years for the sales data that I mentioned. There's also, we always start basically from the same chart. You can align the markers differently, like to the center. You can actually, this is like I think quite special to Ipyzoo. We have an alignment called a stretch, which is going to stretch the markers out, and then you're going to get to sort of percentage view, so you can show the distribution of things really easily. Yes, there is like, then again we get back to normal arrangement. Then you can set the axis pretty easily, and different ways, and then you can switch to, okay, I think the polar part is not here, so yeah, because this is just a line and range. Okay, filtering and adding new records. I think that might be interesting for you. So we are adding, we are baking the same data, and then we filter it by one dimension. So we basically filtered the records based on like the genres data series, and when it equals to pop, or when it equals to metal. And then obviously Ipyzoo simply animates once again between these states. So you can zoom in on specific elements on your chart. You can just draw the attention of the people looking at your chart to certain parts really easily. And then we cross-filter, so we only leave just two markers on the side. This is when we say that, okay, in terms of genres, we only need pop and metal, and in terms of types or kinds, we only need smooth. So it's as easy as that once again. And then you can zoom out, basically turn off the filter in one step. And everything, as you can see, everything goes back to its place, so it's easy to follow. And you can add new records in the data part of the Animate method. Here we add another set of data, and as you can see, the already existing markers make place for the new arrival, and it appears just where it should be. We have a zillion chart styling options, so you can actually change the color palette as easy as that. It might not be that interesting for you, maybe for the developers, but you can use CSS for styling, but I think it's more relevant to the JavaScript people. You can change the font size as this, and as you can see, even the style updates animate from one state to the other. We set back the font size to default value, as you can see, and then yeah, this is all like not that interesting. The layout, I think it might be interesting from the style perspective. We have 3 key areas that I'm going to just change the background color of so that you can see it. We have the legend, we have the title, and then we have the plot. And the styling that we use, it's a hierarchical structure. It's really complex, but in the meantime, I think not that hard to understand. And if you change one style setting at an upper level of the hierarchy, like change all font sizes at once by just style.fontSize and equals 50 pixels or something like that, then all the fonts on the chart will get to that. Sometimes you can do that even proportionally. So there are, like, we again try to make it easy for everybody. You can play with the legend width, and once again, everything is animated, so you can see what you get. And lastly, and then I'm going to get to the examples, animation options. So you can, yeah, it's just the original chart. We have the default way of animating that you've seen many times before, and then let's see a custom animation. Oh no, I still have to run the cells in between. Just a sec. So this is the default version of grouping and then stacking, and still this is the default version. No, this is already, like, as you could see, the chart weights a bit, so the elements move to the right side. Oh, come on. Okay, let's start over. Yeah, so we have this. We group the elements. Okay, and then so it's gonna animate very differently. It just halts for a second. It's separated in the way of movement. You can play a lot. It's easy as that. So for the Y part of the animation, when the markers are moving along the Y-axis, so up and down, then it's like it got longer. Default value for duration is 1, and it got delayed. So it started later than originally. That's why you saw the markers move along the x-axis and then took their place along the y-axis. And then you can actually play with the easing. You can set different duration for the whole animation and things like that. Okay, so one example would be, this is a longer code, some sales data. This is also made up. What I do here is that I'm just gonna filter the data series and add the product categories one by one. So in each case, in each iteration of the Animate method, I add more products to the filter. Here I'm just using an exclusive version instead of an inclusive version. That's why it looks a little different. And then what I do is I'm going to change the amount shown from the sales, so the number of products sold, to the revenue generated. And then I'm going to, just like with before, as I mentioned, aggregate the data throughout these regions. So here's the sales of shoes, and then handbags appear, and then comes, I guess, the scarves. No, gloves, sorry. Yeah, and here are the accessories. Now we change to the amount generated, and then we just aggregate the value. So I know it's a little quick now, right? It's not always easy to follow, but it's a linear story. You can obviously split this up to multiple cells, and like when you want to present your findings for someone in a way like this, you just put the same code into 3 different cells, and then yeah, like this. So I'm just going to add some more cells, hopefully, yeah. Here, and it's gonna get much easier to understand. So basically this means that, no, sorry. So this animation runs only until all the products are shown. Yep. And then, you know, you can talk about like why this is important. You can highlight different elements on it. And then just by running the cell below, we will switch to the sales revenue. And so as you can see, there are important changes there. You can actually make the code like you can go back and forth between these states if that's necessary. And then as the last step, you aggregate the values along the other axis in 2 steps to have an overview. Yes, please.
Somewhat of a question regarding, well, the feature status. In Vizu, there is a possibility to generate somewhat interactive reports, like, so you wouldn't need to, you know, go to different cells, right? In the JavaScript one.
So you're asking about interactivity, right?
Well, what I wanted just to ask is, what is the status of this Python library regarding the complete interactive report generation? Because I'm asking this, or and as an extension of that, what is the possibilities to export that? Because I'm asking this because in a real world case, for example, how I'm doing the similar thing with, as you said, competitors, plot and hash, is that I generate the graphs. I do create interactive controls with the Jupyter widgets, hide everything I don't need, and export the widget as HTML for pretty much easy sharing. Is that possible?
So the question was if you can make interactive visualizations with Vizu using Jupyter interactive controls. What was the name again?
I do export that easily.
Yeah. Okay, that's a different. I mean, you can save it as an HTML. It's gonna work if you save the workbook in an HTML without or the notebook in an HTML without any issues. Actually, I haven't tested using the Java, so the Jupyter's own interactive controls so far. I would love you to you know, make a test run because you have a lot of experience with how Plotly reacts to that, and if anything goes funky, just, you know, let us know and we'll jump on it. Actually, I know that this can, so it can work pretty well within interactive environments. So you can actually embed it in Mercury, for example. I'm not sure if you're familiar with that. It's like a way to create interactive web apps sort of things out of your notebooks pretty easily, and we work with their controls without any hassle. Actually, no one has asked about Jupyter's interactive controls so far, so I have to admit I haven't even been aware that there is such a control set. So we will look into it, but having you put it, I mean, just, you know, playing half an hour with it would be really beneficial. So please let's talk later, if that's okay.
Since we started talking about this,
Yeah.
what would be the best option to actually share the results? Kind of what would be the ways to export it?
So for now, there are options to just you know, export a video, not with the tool itself, but with a browser add-on, or just, you know, recording your screen. If that works for you, we have plenty of people who just, you know, want to embed it in a PPT, and I don't see any other ways right now that it's doable. Later on, so there are, so for example, exporting it to HTML can be an option.
Yeah, like for example, GitHub pages, would that work? What if we publish it on?
Yes. And if not, let me know. But we build things on GitHub pages, and it worked really well over there. Any other questions for now? Okay. So another example that I hacked together, it's actually part of a story that we built. It's about the revenue of the music industry in the United States. And okay, I'm not going to go through the code now because it looks like you're all more interested in the moving charts than the coding itself. Yeah, but I think I just have to adjust the size here because this is like too huge for some reason. Let's try this. I wouldn't say it looked much better. It's just this must be some Jupyter styling issue. Yeah, now it looks. So you have the stream graph, then the percentage values, and then you split it up. And then, as my wife said, so you zoom in on different components. Here, as my wife said, the elephants give a kiss to each other, and then you compare the components side by side. So it was super quick once again, right? I know it's more of like a demonstrational thing, and then again it's so to put it to like I'm just gonna put things up to a couple of cells. Okay, for example, let's put this into another cell.
Sorry, I think if you press Ctrl-Shift-minus, you split the cell.
Thanks.
If you want to try that.
Really appreciate it, thank you. And let me just, this is the split, this is the zoom in. Ctrl-Shift. No, doesn't work for me.
Put the cursor between the
Okay.
where you want to split.
Yeah, this is the, we switch the filter off, and then lastly, this part. So I put the cursor here. Now I have to click there. Okay, whatever. We're there. Maybe too many clicks. I'm sorry, but we're finally there. So in the first part, we have this stream graph, and then we show the percentage views, and we go back to the stream graph. I'm sure it's easy to follow for now. And as you can see, they made a lot of money from vinyl in the 1970s up towards the 80s. That's when the cassette came in, and that's when, CDs was like the high point of generating revenue. And there was this huge like downfall, you can see. And then streaming came along to save the day, and the revenues of the music industry started growing again. Now, just by setting the split option to 2, we are going to split up and see the components one by one. So obviously it's much easier to see the trends. Some smaller players get diminished because of the bigger ones, but you can see much better a bigger picture. This is the point where we zoom in on 2 of the components that had a very different way of life or history. Yeah, it looks like I added one here that I didn't want to. So you see, playing with your code like this, it's not that hard. So yeah, right now we zoom in, and because the split was already turned off, that's why the elephants are on top of each other, not like in the original. Version. But if I just put this here, I'm just gonna split it up again. Yeah, and as you can see, there is actually a comeback of vinyl. More and more people are buying them, and so the revenue started slowly growing again. And yeah, the point when the elephants kiss, and then we switch to the line chart, and so you can compare them side by side in this matter, in this regard as well. You can obviously imagine sales results of different products or from different regions. But I'm actually pretty curious. Where would you use this kind of visualization, this kind of transitions, or what are the use cases that come up? Do you have any ideas from the top of your head? Anything?
I'm just thinking why you think that this is better than to show 4 pictures all together.
4 pictures like side by side.
Like viewers can understand.
Mhm.
Plus, in this case, we also have to remember what we saw before, and if we switch fast.
Mhm. Well, usually, I mean, the question was that why I think it's better than just showing 4 charts side by side. So obviously, it's for once it's a matter of space. So you would have much less space if you have 4 charts, and then you still have to look the change and look at one time and you know, connect the views mentally. Whereas if you can switch back and forth, I mean, we've tested it and we know that it works really well with people trying to make sense of what they see. If you have the ability to like see it from different angles and the views are connected, it's just easier for them to comprehend what they're looking at. That's the answer to that. But actually, yeah. So any other, I mean, maybe suggestions, ideas, questions?
I've seen some of the posts on Reddit, and I think it really is very useful and helpful in showing data over time, and just the change in habits or patterns or whatever. Like, even with this one that you showed us, it's interesting how things change over time,
Mm-hmm.
and having these sort of running animated graphs shows it much better than I pictured.
Thank you. Thank you. I'm not going to repeat that to the to the mic because it's going to sound a little, you know, overly satisfied for myself. But I'm glad you like what we do.
And just the point of our booklet was like some kind of controls so that back and forward would be
I'm
ideal.
so glad you said that. Let me just go to the other tab very quickly. But there was another question over there.
Yeah, I was just going to mention we work on an analytics product. We can see this as being like a marketing tool, possibly.
Mm-hmm.
And then, yeah, this pause, inspect between states would be pretty interesting.
Thanks. I'm glad you say that. Actually, there is a social listening company in the US that is now using, so embedded the JavaScript library into their own tool, and basically they notify the brand manager when something goes wrong or good, with sending them like a short animated story of what they should be looking at from the, you know, different types of data that they are gathering. Okay, so let me show you some examples of what we are planning to do in the future. Oh, sorry, there's another question over there.
Yeah, thank you.
No problem.
I wanted to ask actually, how hard was to program that Trump analyzing thing with the tweets? I mean, was there a lot of code to make that tool? I mean, because it clicked buttons and it was interactive.
Okay, so the question was how hard it was to program the Trump's Twitter thing, right?
Yeah.
So actually, and that's more like, it doesn't have to do so much with the current state of the library, but like how it is to build a technology startup. So back then, when we built that, we only had a specific language that wasn't JavaScript or wasn't anything else. That we had to learn. I mean, I had to learn. There were no states, so you couldn't even save anything into a variable. That's why you had to map out all the buttons, because the program itself didn't know anything about how it is used, and the code itself was so verbose, and because I had to like put every button on it and everything by hand, so it was a very low level sort of script. That at the end of the day, I put the whole thing into a Google spreadsheet where I set the parameters, and then it spit out some code. But yeah, and for example, so the Trump part is like it's hundreds of slides that this script puts together. I think it was, I don't know, like a couple of hundreds of thousands of lines of code at the end of the day. So this is like a different era. Obviously, we could do the same stuff with a couple of hundreds of lines of code now, but
Yeah.
and the data collection was done for us. So there was a guy who collected all the different tweets. Obviously, getting them together and doing the analysis. So there was some data prep headaches, but compared to the scripting, it was easy as pie. Okay, so again, thank you for the question about the controlling the animation, because that's what comes next. We want to give you control over these states. We are actually working on it right now. So it becomes sort of like a presentation that you can run back and forth. So I'm just moving forward in my story. Here are just two animation steps in between two slides. And then I'm moving backwards. I can even use my clicker. Hopefully it works. Yeah, so I can even use my clicker to do that. I truly believe that it would be a crucially important feature for us to develop. And I'm going to get back to my presentation here. So we already work within these platforms, not only in Jupyter, but in Colab, DeepNote, Kaggle, and Mercury. With Mercury, you can build interactive stuff. They work a little differently, but we have that documented, so you will quickly understand. And these are the ones that come along. Actually, I'm very proud of that we are progressing so rapidly that I put together this presentation yesterday, and then one of my developers just called and said, like, okay, we're done with the Databricks part. So Ipyzoo is already available within Databricks, but I didn't have the time to update. And soon it's going to be available in Streamlit. What other platforms should we target? What do you think? Grafana. It's interesting that you say that. Do they have an open API or?
I'm not sure.
Well, actually, Grafana, they approached us a couple of half a year back. They seem to be very interested in what we do, and yeah, I mean, I because of that I got into the product a little bit, but I don't know. They went other ways, and I'm pretty sure it could be put to good use in the Grafana dashboards. But how easy it is to put it together, I'm not sure. We're actually thinking about, so as I said, our final or like long-term vision is to put this, obviously an even more user-friendly version and without the coding part, into end users' hands. But now the direction we took is that we gathered everything that we came up with, all the results of our research, all the rules that we identified, all the design settings that my co-founders, just touched and polished together, and we give it away for free and in an open source way. And we give it to experts like yourselves, because we believe that you are the ones who could, show us the way, who can give us examples, who can challenge us what we should do. And this is basically what we ask for in let's say in response to all this. Maybe a star at our GitHub repo, that also comes in very handy. So if you have some time to do that, I really appreciate it. It's an important thing for us. But to have a discussion and to understand how this could make your everyday work better, or work on a project together even. We are very much looking forward to that. And the novelties that I wanted to add. There's one other thing. So right now I mentioned that you have to be careful when adding new categories on the chart. Things can change not very nicely. Now we're working on the so-called smart transitions, where everything is going to be happening in the background, and we put a little intelligence within the engine so that this fading never happens. And this is like an illustration of that. So moving from a bubble chart to a bar chart, it could be like with a couple of lines of code, and then to a split area chart, it would work again with just describing that chart on the interface, and Ipyzoo will do the rest. And I think there was something else. No, the platforms, the presentation, and the smart transition. That's what I wanted to add. We have plenty of examples. So if you go to ipyvizzu.com, then you will be faced with the option to just check out the description, go to the repository, check out the tutorial that I showed some chapters of, And to go to these examples, so these are static charts, but because obviously you can use Vizu to build static charts as well. This is not the animations, and these are the, oh yeah, here are the animated charts. The animations are not, in this part, are not done by Vizu. These are just, exported anims that for some reason act weirdly here. And if you click on any of the examples, you'll get to the notebook that runs them. So it can be, I hope at least, easy to learn via these examples. If you have any other suggestions in what we should put together to make your life easier, reach out. We have a Slack channel, and also I'm also available. So here's my email address. Feel free to drop me a line, or just follow us on Twitter. Yes, please.
Could you, I have checked these examples.
Thank you.
For me, it was not obvious how to make different chart types. How different types
Yeah.
Because syntax is quite similar.
No, actually, thanks again. So it was like the chart types are not that obvious, because I knew I forgot something about the things that we are building right now, and these are what we call presets. And that's exactly what you're talking about. So as I said, you're more used to I want a scatter plot. These are the parameters, and you will be able to say chart dot not animate. Instead of chart dot animate, you would say chart scatter plot. And then you will have just those 3 parameters to add that are necessary to build a scatter plot. You will still have the ability to tinkle with the code and do whatever you want with it. But it's going to be easier because we figured out that this is actually quite a big burden. And this is the challenge of a generic chart morpher versus all the other charting libraries that are out there, where you first select the chart type, and then you just add the right parameters, and then you can see a chart there. We had a lengthy meeting about the syntaxes just this Monday. It's going to be ready. Oh, this is recorded, so I have to be careful. But I'm quite sure we are going to be able to release it in a couple of weeks, or I think a month tops. I'm also lucky to be invited to EuroPython, and I definitely want to show that version over there. So.
Because it looks very interesting, because it seems that there are just different parameters, but then you just get very different graph.
Yes, that's the generic part. I can explain it to you. For me, it comes very natural because I spend so much time with it. But yeah, I don't know, what's a tree map, right? It's actually a chart without coordinates in the Euclidean coordinate system. It doesn't have anything on the axis. That's what I say, it's without coordinates. It has rectangular shapes. Something can be on the color, and the same thing that is on the color can and should be used to group the markers. It is totally obvious for me, and you're totally looking super puzzled at me, and I understand that. So I mean, this is it. A pie chart is basically a stacked bar chart that is put into the polar coordinates, and then it's aligned so that it's the y-axis of it, where the charts fill out, the elements fill out the whole of the y-axis. That's a pie chart. I know it doesn't make sense to you, but from the generic perspective that I'm coming from, that's what a chart is. And I understand that we have to adapt to your needs and not vice versa. So. Okay, do you have any other questions? Yes, please.
Small one. How big a team is working on this?
Come again?
How big a team working on this?
How big a team? Well, we are 3 founders. We are working on it full time since we've raised that round of funding a little more than a year ago. And we have 5 more people helping us out, most of them all of them part-time. So we are still a small team. I think we've come quite far, but I might not be objective enough to evaluate that. Yeah, we feel that we have a long way to go, and we hope we'll get there. And you can help us out. So if you liked it, and if you think you wanna just spend an hour if you're playing with it and letting us know what you found or how you think we could improve, I'd be really glad to hear that.